receiver is 12th location. The receiver will store all the readings corresponding to 0 to 360 degrees over its memory locations from 1 to 72. After the rotation, we will dump the data from the receiver into the software. We'll show you how it is being done. We see we have a cable which is connected from the back of the phased controller, which is it is a 9-pin cable which is coming from the phase array controller. This cable is carrying the DC voltages which are being used for the phase shifts. We need to ensure that since the antenna is pointing towards the back wall, we need to ensure that these walls are sufficiently away from the antenna under test. Now this antenna will point to some extraneous object. We would advise that you perform the experiment in the biggest room you have available in your lab. That will allow you to have the truest pattern of the antennas. We need to be away from the antenna at all the times while the pattern is being plotted, because any movement in the room will result in blips in the plot. We need to ensure that the log periodic antenna is also in the horizontal plane of polarization, so the polarization of the transmitting antenna and the phased antenna should match. Right now this is in the horizontal plane and it is pointing to the center of the phased array controller, and the height is kept at the center of it. Now you see it has reached 61, 62. As it reaches 72 locations, and the stepper motor controller will stop. In that case, it will stop automatically. Now just wait, just take you a few more seconds. Once it gets there, because the phased array system is a narrow beam antenna, we advise that the initial position, instead of being kept aligned to the transmitter antenna, we would advise that for precise resolution of this particular narrow beam antenna, the patch antenna or the phased array system is rotated by say 90 degrees in the initial condition. It could be pointing in say this direction or any direction for that matter which is known to us. We can say this is the 90 degree. We can use this as the start location, and the antenna plot can be rotated in the software later on. This allows for better stitching of the pattern when the antenna has come back from 0 to 360 degrees. Since this is a narrow beam antenna of few degrees, 20 or 30 degree beam width, then few degrees of stitching overlap is not required, and we are most of the time interested in the performance of the main beam rather than the patterns of the side lobes. The main beam is our primary focus right now. Now you see the stepper has stopped automatically and the receiver has stopped at 73 location. Now we are using a laptop computer right now. It doesn't have a COM port, so we are using a USB to RS232 cable. The software has been installed on the computer and the registration file has been put into the C drive, the details of which can be had in the software installation details. Now when the software is connected to the receiver using a RS232 cable, when the software is clicked, it asks for the COM1 or COM2. These are the only two ports it asks for, and because of the memory allocation, it may at times skip asking for the COM port. You please ensure that it has asked you for the COM port. That means it has detected the COM port, and you need to make sure that you select the corresponding USB port and do that setting of the port so that COM1 or COM2 port is available and is what is selected here, and we will connect this RS232 cable to the software. We press the menu button and we bring out the system from the auto mode. Now we press menu again, press menu again, press menu again, go past the step sizes, go past the recall mode, and it asks for serial mode. Yes, I'll say enter. Now uploading the receiver data to the computer, we need to ensure that the computer has selected the proper COM port, which will display the status LED as green. We'll try to attempt that thing again.